Hello and welcome to Badger Talks Live, which brings exciting happenings, resources, and talent from your UW flagship campus to the state of Wisconsin and beyond. My name is Aaron Allen. I'm a rising junior here at UW-Madison, and I'm majoring in industrial engineering through UW-Madison's College of Engineering. And it is my great pleasure today to introduce the Director of Granger Engineering Design and Innovation Lab, Lennon Rodgers, to give us a personal tour of UW's Makerspace. The UW-Madison Makerspace is part of the Granger Engineering Design and Innovation Lab, along with the Team Lab and the Kohler Innovation Visualization Studio. It is here that students can use millions of dollars of high-tech equipment to bring their resources and dreams to life through a variety of scales and designs, from micro to macro, virtual to physical. I know that I myself have used the Makerspace on many occasions, one of which was in attending one of their many workshops that they host for students, in which I used the Twitter API to build a sort of bot using a Raspberry Pi controller, learning a little bit about coding with that. And as well, during one of my project-based classes, in which we used the Makerspace several times to procure materials and generally to help in consultation and design throughout the course of that project. So with that, without further ado, please welcome Lennon Rodgers.
Hello. So I'm really happy to give you guys a tour today of the Makerspace. I'm going to be walking you through the facility. And because of that, I have this mask here, which I am wearing inside the building. So I'll throw that on. And I'll also flip my camera around. But there will be definitely time at the end to ask questions. You can also just put a question that you have in the chat window, and don't feel any hesitation to just ask anything that's on your mind. All right, so this is the entrance to the Makerspace. It is just one of a few facilities that's in the Design Innovation Lab. And I just kind of wanted to give you the experience of what a student would experience when they're walking through here. What's kind of unique about what's going on now is that we've been quite busy actually since March on a lot of COVID-19 related projects with the hospital initially for the first few months. And more recently, it's actually with campus. And so I'll highlight some of those projects as we go about the space. And it's a neat way to show you how some of the tools are used and some of the courses that we offer, the things that we're teaching students. So right off the start, here you go. You can see that we've got a sign here that says "Welcome to the Makerspace." This is a project actually that I'm working on right now, and so is a colleague of mine. And what this is you can see here the campus is putting these hand sanitizer stations around various spots. And what we've prototyped here, which is this box, is an infrared no contact thermometer. So it will be able to sense people's temperature. They'll walk right up to it. This is a very rough prototype, but they'll walk up to it, they'll put their face about right here, and then it will beep, and then it will display the temperature right there. So again, these are the type of things that students can make in this facility using the electronics and some of the other tools. Down here is something actually that a colleague of mine made. It's this clear acrylic holder that's going to hold some masks there for people to be able to get access to some masks if they don't have one of their own. So that's just an example of how we're able to teach students about design process and quickly prototype some things that satisfy a need. So if you were to come over here, you'd kind of peer in the window. If you give just a normal tour, and see some of our 3D printers in there. I'll go ahead and walk you through there and we'll take a look. So typically we'd have a student staff member sitting at the front desk there, and students would swipe their ID. But right now we are officially not open, like a lot of campus, or most of campus, I should say. But a student might come in, and 3D printing is one of the most popular things that students need to do. And 3D printing is essentially when you design something on the computer in 3 dimensions. So it's an actual object that you want to be able to use in an engineering design project. And then what you can do is using plastic and these machines, it prints it out. And I can show you some examples as we go about the space. But we have a lot of different types of 3D printers. So you can see these orange types here. This type uses a laser to cure a resin that hardens. And then some of the ones that we just passed, the white ones over there, you can see them over here on the left. Those just heat up plastic and squirt it out of a nozzle. So it's kind of different methods, different pros and cons for the different types. And one of the things students can do is they can come over here and they can look at the different types of materials. They may not know what type of material they want to use for their project. So some of the staff have gone through, and these are different types: PLA, tough PLA. These are different types of rubbers and plastics in general. And students can decide, based on the type of material they want, then the type of machine. These are the white machines, and these are the orange machines that you saw there. And then the Stratasys machine down there, there are different types of materials you can see here. Actually, this is quite flexible. So it's really neat, the different types of materials you can use. I'll show you here actually. Here's an object that's actually been printed. So this is probably for research, because we're doing a lot of research projects now. And again, this was started in the computer. And we can see here that this is for a research project. It's some type of heel cups. So it's some biomedical application. And this 3D printer is really interesting because it can print very strong parts. So it uses fiberglass filament inside plastic. It kind of weaves it in there and creates really strong parts. So if you look off to the right here, this is what we call our create space. So it's a place typically where students collaborate together, they study, they can work on electronics, anything that really doesn't require heavy duty tools. They can be in here working, and usually it's quite packed. Over here, what we call the studio area. For the most part, we use this area to teach workshops. So during a normal semester or an academic year, we would have 1 or 2 workshops most nights. And workshops are just an opportunity for students to come in and be taught a topic by our student staff, typically, about various things like 3D printing, some of the things you saw already. It could be on electronics, it could be on software. So we've had 1,000 plus different workshops since we've been open the last 3 years. We also do have some machines over here. So these are sewing machines. And I must say that I never really had a huge connection between sewing and engineering until COVID hit with the need for PPE. And there's been a huge amount of textiles, which is sewing projects that we've been working on. And I'll show you some of those over here. So back in March, I was contacted by the hospital, and they were looking for someone to make 1,000 face shields, the UW hospital. And it's just a coincidence, my wife is an anesthesiologist at UW hospital. And so I talked to her about it. I was like, I got this weird email. The hospital's looking for some face shields, and I get random requests every once in a while. But she actually kind of escalated the issue, because she's like, yeah, that's a real issue. We're really running out of PPE. So again, this is back in March, when New York was kind of having its issues and everyone was seeing that go down in real time. So long story short, we formed a team with a company in the Madison area called Midwest Prototyping, another one called Delve. It's a design consulting firm. And the result was this first face shield here. Let me see if I can point you down here. So this is the face shield. It's a little crooked on this mannequin. And this is what we call the Badger Shield. And in a matter of a week or two, we created a design and we prototyped it many times. And then we released the design open source on the internet. And it actually went viral. So the design went quite viral for many reasons that I could explain if anyone's interested. And it ended up, fast forwarding to today, there have been 20 plus million of them made around the world. So it was a really neat experience. And it really, like I said, leverages the ability to make and prototype and collaborate around a need. Well, about, I guess, a couple months ago, so it was a couple months after that first interaction, we were approached by the hospital again. And the result, I'll kind of skip over the details, but the result was this PPE item here, which is called the Badger Shield Plus, because it's a Badger Shield, which is the face shield, plus some fabric. But there were actually, as part of this is the end. One of the things that we teach students to do is to prototype and rapid prototype. And rapid prototype means very quickly. So you try to generate as many prototypes as you can as quickly as possible. And the point is to learn. So you want to be able to learn what you don't know in terms of the different types of materials, what is actually needed by the user. And so these were mostly done by the shop manager in the Makerspace. His name is Carl Williamson. And he's just an amazing designer. He not only runs this facility, the Makerspace, but he is a talented designer himself. So since the students were gone, he and I have been full throttle on some of these projects, and this is an example. Well, kind of in between, I would say, the two that I just showed you were a lot of other projects. So we worked for a good 2 months solid with the hospital on various projects, and these are just some examples. So this is one that was mostly made by Delve with some of their partners, but we also helped. And it is what's called a papper. So it's a very enclosed type of PPE where air is blown through a hose that's in the back from a blower that the doctor or clinician just wears around their waist. And then the air circulates through their face and keeps them safe. This was one that we invented that really doesn't exist. And it's a similar version of the normal one. This one does exist and it's very popular, this style. This one doesn't really exist. And so Carl and I developed this over the series of a month. And it's what we call the compact papper. So I'll skip over the details, but it's an interesting design. And like I said, we've worked on a lot of different projects. A lot of them are not even shown here. But here's some examples of kind of along the process. So these are some sketches that Carl made as he and I were collaborating together to kind of form what you saw in front of you. We also printed out the different prototypes on foam heads and asked for feedback from the hospital. So we got a lot of feedback from them. So that's kind of one of the key things that we teach in our design courses is really just getting that feedback from the hospital or whoever your user is. All right. I'll just pause here for a second. So one interesting thing about the Makerspace is, as I mentioned, it has a lot of student staff. And so it is essentially a student-run facility. Carl, who I mentioned, is the shop manager. But we have about 30 student staff here that run the Makerspace. Team Lab, which is the machine shop, has about 30 student staff as well. So it is student run, and the students provide design consultations to other students. So there's a peer learning component to it. And they also do all the maintenance on the machines. And so here's just an example of a little bit more complicated machine, I would say. And it's also more expensive. This is a laser cutter. And what you do is you load your material in there. And again, it's all computer-based design. And then what this laser cutter does is it cuts sheets of plastic, fabric, wood. So here's another example board here of the different types of materials that students can purchase actually at the Makerspace and then cut on the laser cutter. So it's actually one of my personal favorite tools. I like 3D printing too, and I actually like it all. But laser cutter is extremely good for making very fast, again, rapid prototypes. So here's just an example, and this is a true story. So I woke up very early this morning, and I had this thought on how to modify a dock camera that people use in classes, because I think now a lot of teachers and TAs, instructors are at home, and they're not able to project notes that they're maybe writing, because they would normally write them on the board and things like that. So we've been working on this on the side, but I had this idea for a new idea this morning of a way to use your cell phone. So instructors could be on a video chat and place their cell phone on top of this, and then they can be writing notes down below. So this is a way to capture notes. You can be writing here, and then you can be in a video chat up here, and you can just place your phone on there, and then the students can see what you're writing. At the same time, let's say you want to go back into face chat mode, you can put your phone there. And then so you can be corresponding with the instructor. So this is kind of an interesting design. Like I said, I just thought of it this morning, and I was able to use CAD, which is the computer-based design, and then use the laser cutter, which is what was made out of this wood, how I made this object here out of wood. And it took me about 2 hours to design it on the computer and about 5 minutes to cut it on the laser cutter. So the laser cutter, like you can see here, it uses wood or plastic and it just cuts, and it's very fast. It's almost the speed that my finger is moving here. So it can just cut extremely quickly, and it does exactly what you have specified in your computer file. So extremely powerful tool. And you can see here that this came from a essentially a early morning dream to reality very quickly in the matter of just a couple hours using the laser cutter. And so that's exactly the type of thing that is possible for students in the Makerspace. All right. So if let me see here, my camera oriented. All right, so this area is the electronics area. We run workshops over here. Like I mentioned, the workshops, again, opportunities for learning, just an interesting topics pertaining to electronics. So electronics are really fun because you can control things. I showed you guys that thermometer out in the hallway. That was made here. In fact, I made it right at this bench right here. It's a little messy right now because it's essentially my personal workbench. But it's, again, a place for students to prototype anything to do with electronics. And electronics are sensors, essentially, displays, very useful things to include in your engineering design. So there's, like I said, this is the electronics area, and it's very popular among all students. Electrical engineers obviously enjoy it, but so do mechanical engineers. I'm a mechanical engineer, and many others. So this is the machine shop area, and it is essentially what I call is a satellite to the full machine shop. It's definitely a complement to that, but we have a full machine shop as part of our lab that's it's in a different building, and it's about the same size as the Makerspace, so it's quite large, and it has a lot of staff to help students mainly do metal work, so things called mills and lathes and welding and things like that. This shop here, like I said, is a mini version, and it's mainly for prototyping out of wood and plastic. So it's not as much about metal, and it's more about to do with wood and plastic. And the reason why is that you can prototype very quickly out of wood and plastic, and hopefully you saw some examples here. And so that's really what the Makerspace focuses on. It's also these, some of the machines, this isn't a good example, what we're looking at now, but some of the machines I showed you, the 3D printers and laser cutters, those are also quite safe for students to use. And so there's not as much oversight that's needed as compared to some of these items in here, like a table saw, and also the mills and lathes and other things. So there's different types of safety considerations that we offer through training and through our policies and procedures. I'll mention just a little bit about some of the training that is offered, and it's quite amazing, actually. Engineering students can come in and they can be trained as part of just being a member of the College of Engineering. They can be trained on all the tools that you saw. They can get formal training on a lot of the tools in the machine shop. So they can actually be formally trained on how to weld, how to use the mills and the lathes, metalworking. You can get trained on a lot of the things inside the Makerspace through the workshops, and we do offer some formal training here too. But I guess all that to say is that there's quite an elaborate training program that students can elect to be part of just by being a student here. You don't have to be a certain major or anything, and it can be part of your course, or it can be just because you enjoy it. So I was a person that has enjoyed making for a very long time, though engineering is not all about making. There's a significant opportunity to make, and so I think a lot of students, it really resonates with them, and some of them are just curious and they come in and check it out and they really grow. So it's really neat to see that. So this is another machine here. It is called a router, and A router is a tool that essentially cuts in three directions, so kind of left, right, forward, backwards, and up, down. So you can do three-dimensional objects on this router. It's quite amazing. It has a cutting blade, or cutting tool, I should say, on the head there, on this head. And again, it's computer-based. So students would design where they want the tool to go. And then this thing is very loud. It spins very quickly. And then we'll move along this gantry here. These are the gantries. And it cuts. And it cuts mainly wood, but it can cut also aluminum and plastic and other things. And this is an interesting tool because there's a lot of furniture. Well, there's a lot of things you can make with it, but I think the thing that most people understand is furniture. And I always explain it that most of the things you see at IKEA that are shipped in a flat pack, they could be made on a router, and a lot of them are actually. In fact, I wouldn't be surprised if IKEA uses almost the identical tool that we have here. So here's an example of a stool that students, as part of this formal training I mentioned earlier, they can learn how to use the router. And as part of that, they learn to make this stool, which is cut on this machine. And you can see there's two pieces on the bottom and there's one piece at the top. So it's a really slick design. And Carl came up with that. And he teaches students how to use the router by making a stool. All right, I'm gonna skip over some of the tools, but if you have any questions, feel free to ask about anything. Well, again, kind of flipping back into student experience mode here, we have a lot of tools and other things that students can check out. So here are some tools that are just available to use. You don't need to do anything, you just come up and use them. They're considered pretty safe. Things that need a little bit more oversight, students would check out at this window here. It's called the checkout window. So you can see the checkout window. And normally that curtain would be open and we would have student staff behind and they'd say, a student might say, I'd like to buy some material for the laser cutter. And so you can come over here and students actually could walk right in here, just like I'm doing now. And I'd like a sheet of this, I'd like a sheet of this. And then you can buy it with either a credit card or your student ID. You can also buy nuts and bolts. Imagine a hardware store. It's essentially, this is my personal dream, was always to have my own little hardware store here. So that's what we have, which is awesome. We also have a lot of electronics. So you can buy a lot of different types of electronics. We have some resistors in there and some LEDs, and we have microcontrollers and we have batteries, and you can buy sandpaper. So we really try to make it easy for students to, again, quickly, rapid prototype. They still order a lot, but when you're trying to make a prototype, like I mentioned this morning, when you wake up with an idea or you're working on something, you really want to get it done. You really need to be able to just have it right there on campus. Here's some other material. Like I said, for the most part, the Makerspace is about plastic and wood, but sometimes you want to use a little bit of aluminum or steel, and we have a cutter back there I didn't show you, but it's called a water jet, and it actually uses a very high pressure stream of water plus an abrasive garnet to cut through this material. So it's again, computer-based designs, and it's really neat. I love the water jet. So here are all the tools that students can check out, and there's some materials or some supplies in here like glue and things like that. But there's drills, there's hand tools. And here are a lot of different kits that students can check out. So these are kits that students might want to check out to learn about sensors. You can see here's a sensor kit. And so the building that we're in right now used to be a library, an engineering library, before it was the Makerspace and some other things. So in some ways we say that we try to preserve the spirit of the building, which is a library. And so we allow students to check things out, but instead of books, they're more about technologies. So we're trying to provide easy access to technology for students. So here's a little bike stand that students can work on their bicycles. All right, and I'll answer some of the, I saw there was a question there, I'll answer that in just a second. So this is a room, I don't know if you can see it if I turn the light on here. This is a technology called 3D scanning. And let me see if I can open a 3D scanner up here. But 3D scanning has also been extremely useful for COVID projects. And so we were approached by some surgeons that said that they love the face shield, but it doesn't quite work for them because they wear headgear and it was getting in the way. So we were able to basically scan their headgear. So headgears are like these optics that they wear on their heads. And so you're able to 3D scan them. So this is a 3D scanner, and that brings it inside the computer. So you can again see the theme here that it's always about designing. A lot of it is about designing on the computer. A lot of it we do by hand too, but in this case, it's designing on the computer. So it's getting that scan of a real object into the computer, and then we can design around that headset. And so Carl and I, for quite a bit of time, we're scanning different types of headgear used by surgeons, ophthalmologists, and we created a lot of custom face shields for them. But there's a lot of really cool stuff you can do with a 3D scanner. This is again, an option for students to learn about and to use for their projects. You could scan your a hand or a body or whatever, really anything you want to scan. An interesting project that we did was with IndyCar, actually, the race car, and we went to Road America and we scanned some of their parts, and we were looking for differences between parts. You know, there were different types of wings that the car uses on the front and the back, and we were trying to understand why they were performing differently. And one way to do that is to 3D scan them and then compare them in software, like analyze them and try to understand, was there a geometric, you know, was one slightly fatter or thinner than the other? So that was a neat project. And we've done a lot of different projects with 3D scanning, from biomedical to race cars. All right, so I think that's kind of the basic. I'm gonna sit down here so I can take my mask off. And let me flip my camera around. And let me go to the chat window. All right, so one of the questions was, do we receive any kind of, do we get any patents on any of the designs that we did? And I guess the short answer is we have not received any patents on any of the design work related to COVID. But we have worked a lot with WRF. There is a kind of an interesting thing right now is that, you know, WRF is actually, WRF is the patent arm of UW. I mean, they're very interested in some of them, but so far it seems like we've submitted them and they haven't been picked up for a patent. So then the other related question was, do the designs belong to the designer or the school? And I am not a patent expert, but my understanding is that there's a lot of rights for the inventor. So a good place to look would be on WRF's website. But in general, my understanding is that WRF is quite generous in terms of patent rights. All right. And then I had another question. Let me see, let me make sure I'm good here. So they were asking about the most memorable projects that I've worked on here. Well, what's interesting about working here, so I've been here 3 years at UW, and I actually have not had a lot of opportunity to design and build before COVID. I've been largely building a facility that builds things. I haven't done tons of projects myself before COVID. Now, once COVID hit, we worked on tons of them, and I kind of shared with you some of them, and they're all quite memorable, and they've been really enjoyable because I enjoy to make and build, but I normally don't get an opportunity to do that as much. But I have helped quite a few students with projects. And I'll just give you one example of an interesting one. I mean, I'll kind of give you a sampling. They're all pretty good. We've had students come through here and they've created 3D metal printers and started companies. We have, and this is just in the last 3 years. And we've had another student that started a company about to make digital locks that are all activated over the internet, kind of like smart locks. We've had a lot of projects with the vet school. Early on, we created some tools for a neurosurgeon that were really neat. So yeah, there's a lot of projects I work on with students here. Before coming here, I worked on a lot of projects myself, partly as a student and then partly just as an engineer. And so most of those were either related to electric vehicles most recently, and I also worked on a lot of telescopes and spacecraft before as an engineer. All right, so Betsy's asking about what will the fall look like in the Makerspace or for the Makerspace? Now that's a great question. We do have an FAQ page on our website if you'd like to know the gory details. So if you go to making.engr.wisc.edu, on that main page there is an FAQ page kind of outlining what our plans are for the fall. In general, I guess the high level is that we are going to be open. We are open for a much smaller number of students in terms of traffic. We'll have reservations, a reservation system where students can sign up for a slot, and we're just going to keep that number down based on the UW, the broader policy of social distancing and people per square foot. What helps us is that we have a very large facility. We have something like 50,000 square feet total among all the different shops. So we have a lot of space to work with. But even with the spacing, we're creating protocols for cleaning and encouraging students to clean. And then we'll also just continue. So we'll continue to support design courses. We're also continuing a lot of different COVID projects, and so we have a lot of those on the horizon. All right, Nancy's asking, do you see students who were engaged in STEM programs in their secondary ed? How do you feel the STEM program has helped the students? That is a really super interesting question because I am too old in some ways to have experienced it myself. I mean, in the sense that when I went to school, I guess there just wasn't as much of a focus on STEM. So I have a lot of contrast when I do see students come in, and a lot of them come in now, and they've had it makerspaces in their high school and their junior high, and it's very clear, who those students are. Usually, they're definitely ahead of the pack. A lot of them we try to hire as student staff. So actually, I would say in summary, I think that the focus on STEM education has been really impressive. I think in some ways, higher ed, like universities, are catching up, but in some ways, they're still a little behind in pedagogy in some ways. So yes, I think it's noticeable and it's really impressive. And the students that really participate and engage, it's such an amazing opportunity for students. That will help them get into college, that it's really neat to see that as an option for students. All right, so I'll close the chat window here. I don't think there are any more questions. My understanding is that they'll put some of the links and references to the Makerspace website, the Team Lab website, and maybe a couple other websites I'll throw in there. Related to what you saw today. Don't hesitate to, I guess, first check out our website. That's the best source for comprehensive information. It's a little clogged up right now with some of the COVID projects, but if you go to our website, the Makerspace website, you'll see a lot of those projects that I mentioned. And I also want to mention this will be on YouTube and Facebook, is my understanding. And but feel free to also just reach out. You can send an email. There's a general email that will eventually make it to me on our websites in maker-contact at engr.wisc.edu, or you can find my email in the directory and email me that way. But feel free to reach out if you have any questions. But thanks a lot. It's been great giving the tour, and I hope you guys saw something new and interesting